Hello friends, this is Durga again from IT University, a one-stop shop to learn all the technologies. At this time we are talking about setting up of Hadoop using Cloudera. At this time I will be covering how to set up Sqoop using Cloudera distribution. Again I am using AWS as the platform, but same principles apply for VMs also. It is pretty straightforward to set up and we will go through the steps. So we will follow the same learning pattern. First we will understand the architecture, we will see what are the daemon process, parameter files, log files and validation. Again daemon process, it is not applicable because Sqoop is also client only tool. There are two versions of Sqoop, Sqoop and Sqoop 2. I am not going to cover Sqoop 2 at this time, I will defer it for later point in time. For now I will be covering Sqoop. So the daemon process are not applicable for Sqoop. Parameter files are not applicable, means there are parameter files under the etc Sqoop conf, but it's little bit different than the other tools, so it's more like not applicable. And then log files, again there are no daemon process associated with Sqoop, so there are no server side logs. When it comes to logs that are generated for Sqoop jobs, again you have to go through the MapReduce jobs that are generated to run these Sqoop jobs, and we will finally validate after the demo. So agenda, we will see the overview of Sqoop, we will get into the architecture, we will set up how to we will set up using third-party wizards. For this session we will be using Cloudera. We will see what are the parameter files, log files and demo. Sqoop is a MapReduce based tool that can be used to copy data from relational databases to Hadoop and vice versa. So in most of the Hadoop projects, getting data from relational databases into Hadoop or vice versa is very important, and Sqoop can be used as a tool to do so. So if you don't use Sqoop, you need to develop the MapReduce code by yourself, which can be daunting and tedious. For that reason, people have incubated this project of Sqoop in Apache, so that if people want to copy data from relational databases into Hadoop or vice versa, a much developer-friendly tool such as Sqoop can be used to do so. It is written in Java and open source. If you want to modify, you can reverse engineer the code and you can start customizing the code as per your needs, because it's completely open source. It uses JDBC for database connectivity, and it uses MapReduce framework to connect to the database and then load data into the HDFS. So again, we are revisiting the Hadoop ecosystem. We started with Hadoop core components. HDFS is the foundation for everything. Then MapReduce based tools will be there, and non-MapReduce based tools will be there. Sqoop is considered as MapReduce based tool, so we have to use the same architecture as with any yarn plus MapReduce based tool to set up Sqoop in the cluster. So here we are actually using 7-node cluster on AWS. We started with setting up YAM repository server, and then we set up Cloudera manager, which has a database, and then we set up Cloudera agents so that they actually send the data to manager to consolidate and report to the users. And then we set up HDFS, then MapReduce plus yarn, and then we set up pig, then we set up hive with Metastore DB. And now we are going to set up Sqoop. So this is the Sqoop architecture. Sqoop will be run from the gateway node, which is master 01 in this case, and then it will when we actually run Sqoop import command, what it will do is it will initiate a MapReduce job. Actually, using MapReduce framework, it will initiate a map only job. This map only job, what it can do is it can connect to any of the source databases based on the JDBC URL you are using. Connect to the source database, start pulling the data, issuing a select query using certain conditions, and then load data into HDFS. So this is the typical Sqoop architecture. So it is a map only tool. We can use only command line. It is not very secure. That's why they are coming up with something called Sqoop 2, which is not very famous yet. There is no client server architecture, it's only client based tool, so there won't be any daemon process associated with Sqoop alone. It is not easily extensible and no separation of duties. So this is one of the limitation of Sqoop. When we say not easily extensible, if you want to add Sqoop, if you want to add logic to connect to one more database and start pulling the data to the existing code, it is not very easily extensible. You have to reverse engineer and you have to modify a lot of existing code rather than just adding it as a new module, because it is not extensible and there is no separation of duties. So again, the same thing, when you run the Sqoop import command, there will be map only task which will be connecting to the source database, and typically the job will be running using multiple threads. By default it is 4, and for each all these 4 threads have to process mutually exclusive data set. For example, if there are 1000 records and if this map reduce job has to connect to the database and pull those 1000 records in 4 threads, each thread should approximately pull 250 records, so that we only get 1000 records as the final output. We should not lose any data, or we should not have duplicates because of this. So the tool should be smart enough to divide data into mutually exclusive subsets, and it should not miss any data while doing the Sqoop import. So the map task generated by Sqoop code is capable of doing so. So depending upon the source database, it will connect to that, and then depending upon number of threads you want to use, it will distribute data into multiple buckets, and each thread will actually load subset of the data. For 1000 records, if the parallel degree is 4, each thread will approximately pull 250 records and store into HDFS. Okay, now we will understand how that split logic work. I told those 1000 records will be divided into 4 buckets. Now we need to understand how that logic works. So if you are familiar with RDBMS databases, each table will have a primary key. The characteristic of primary key is that the values in the primary key column are not null, and they are unique. So the values does not repeat. For example, in an employee table, employee number will be unique for all the employees. So the primary key means when we create tables such as employee, as explained, the primary key will be employee number, which will be not null and which will be unique across the table. And then first it will get the minimum and maximum values for those 1000 records. So if the minimum value is 1 and maximum value is 1000, it will first get those minimum and maximum values. Once the minimum and maximum values are retrieved, what it will do is it will subtract the minimum value from the maximum value. So in this case, it is minimum is 1 and maximum is 1000. So 1000 minus 1, 999 records. All right. Actually, it will subtract maximum plus 1 minus 1. Maximum plus 1 minus minimum, which is 1000 plus 1 minus 1, which is 1000. So once we get those 1000 records, it will divide by 4. So 1000 by 4 is 250. So now each thread will generate a where condition while querying the data from the database, which says 1 to 250, which is 1 to 1000 by 1000 divided by 4. And then for the second thread, it will be 1000 divided by 4 plus 1 to 251 to 1000 divided by 4 plus the previous value, which is 250. So like that it will divide into buckets. So the first where condition will be 1 to 250, the second where condition will be 251 to 500, third where condition will be 501 to 750, and the fourth condition will be 751 to 1000. So Sqoop will generate these queries using this split logic, and then those queries will be executed against the database by connecting using JDBC, and then the data will be read over the network within the same MapReduce job, which have issued the queries onto the database. Each map task will be issuing its own query, 1 to 250, 251 to 500, 501 to 750, 751 to 1000, etc. And then it will start writing data into HDFS. Without primary or unique keys, import process only uses one map task by default. Means you should specify the number of threads as 1, or there is a workaround which you don't need to worry about it at this time. For if you want to understand all the syntax and semantics of Sqoop, I have the videos already on my channel. You can go through those things. But you need to understand the split logic, so that if you, as an administrator, if you have to troubleshoot the issue, you have to see whether the data is being divided evenly across all the threads which are trying to process the data, or read the data from database and load into HDFS. And then there is a concept of Sqoop incremental load also. You can leverage that to load on daily basis. So initially we use baseline load, and then we have to set up incremental loads. Again, this has to go through complete development life cycle, and you have to come up with a framework which can run by itself. Only thing is, you need to understand if there are any issues, it has to be reported to you. So the application which is developed by developers should be smart enough to do all these things. So they have to come up with a complete data integration framework. The administrator's role will be only to set up Sqoop and also to validate or troubleshoot the issues. His responsibility will not be, or should not be, ownership of the data integration which needs to be done from relational database to HDFS on regular basis. And then Sqoop import is to get the data from relational databases such as Oracle, MySQL, etc. to HDFS. If you want to copy data from HDFS to relational databases or any other type of databases, you have to use Sqoop export. When it comes to Sqoop export, the map tasks that are generated as part of the Sqoop export job will read data from HDFS and write into the target databases. So Sqoop export is to get data out of Hadoop based systems into conventional databases or NoSQL data stores. It also uses MapReduce framework as Sqoop import. At this time, it only understands HDFS. So this is the limitation. So if you want to capture delta from HDFS, you cannot use Sqoop directly, because Sqoop cannot issue a query on Hive tables. So you have to couple with Hive queries with Sqoop to actually get the delta. Again, it has to be taken care by the developers. This is a huge limitation. If you want to capture delta from HDFS to Sqoop, HDFS to relational databases, Sqoop cannot do it by itself. First, you have to execute another program which will capture delta and store it in a dedicated directory, using which we can perform Sqoop export. Sqoop export only understands the directories and files in HDFS, but not it cannot go into the data and filter out to capture the delta. It also splits data, but it uses HDFS splittable logic. So when we run MapReduce jobs, data will be splitted based on the block size of the blocks of the file, and then will be processed by the map tasks. The same case is applicable with Sqoop also. Sqoop uses the underlying files splittable logic of HDFS to process data in multiple threads. So Sqoop considerations, you need to customize, or you need to propose the customizations to developers to leverage strengths of underlying source or target conventional databases. So each database have its own limitations and workarounds. So administrators have at least minimum knowledge about those things, so that they can actually suggest the developers what needs to be done as a workaround of a issue. We should determine number of mappers and outliers more accurately. because in a data set there can be outliers. For example, for 1000 employees, let's say you have 1 to 999 and the last one is 10,000. So your maximum is 10,000 and minimum is 1. Okay, and then when you try to create the buckets, 1 to 2500 will go to one bucket, 2500 1 to 5000 will go to another bucket, 5000 1 to 7500 will go to another bucket, and the rest of them will go into the last bucket. But all the out of 1000, most of the records 999 are within the first 1 to 2500. So only one map task will process the entire data, other map tasks will be created and killed within no time, and it could be a serious issue as part of using Sqoop. So to fix that issue, you have to identify the outliers and use other features of Sqoop, such as where condition or Sqoop query, and filter out those outliers. And there is another feature called boundary query also to filter out the outliers. Typically, outliers are fictitious data which will not have any business sense. They will be created for testing purposes. So you can discard those outliers to get more balanced performance to process the data. This one is already covered. Compression, don't need to worry about it. I will talk about compression little bit later. So set up Sqoop using third-party tools. It's very easy. It's a client-only tool. You just have to add it using add service, and it will be added in no time. Sqoop parameter files are not that important, as it is MapReduce based tool. It uses XML files created for HDFS and MapReduce or YARN for most of the parameters. So first let us set up Sqoop, and then we will see. To set up Sqoop, you just have to click on this, click on add a service. So now you can see we are talking about Sqoop 1 or Sqoop. Sqoop 2 is more advanced version and it is still not very popular. I will try to cover later. Click on continue. Okay, so we just have to configure gateways. I am using all. You can use all, but you should only run MapReduce jobs on the designated gateway, which is 242 in our case. Hit on continue. And now it is deploying. It will take no time to deploy it. It will only take 1 or 2 minutes. So hit continue. Click on finish. And Sqoop is available on our gateway. So now let us see where our MySQL database is running. And to actually run Sqoop jobs, you should be able to connect to the MySQL database using JDBC. Then only it will work. Okay, I am exiting from this window. Quit. Clear. Let's see whether I have MySQL or not. I have the MySQL on the local host itself, so it will be a little bit easier. So to actually use Sqoop, first you need to make sure you have the right version of MySQL connector. Here you can see there is a MySQL connector 5.1.17.jar. Because we have installed MySQL connector using yum install earlier when we actually set up MySQL on this machine. So whatever machine you are trying to connect using JDBC connector with the tools such as Sqoop, you have to first install MySQL connector. So in this case we already have. If not, you have to use this command yum-y install MySQL connector Java, and it will take care of downloading the jar file and creating the soft link the way it has done here. So this is the soft link which will be used to connect using JDBC. So in case if there are any bugs or anything, you have to upgrade this one and repoint the soft link to the latest version of MySQL connector. Okay. So now we will validate whether Sqoop is working or not. There are other commands also, such as eval, list databases, list tables, etc., to show whether it is working or not. So list tables -- connect. Here we have to give the JDBC MySQL, okay, and our host name on which MySQL is running, .ec2.internal. 3306 is the port number, so you can use this one. And then username, root. I should not hit enter. I have to use this backslash to go to the new line. Okay. Okay, and then -P, which will prompt for the password, or you can actually give password like this and give the password directly here. So I will be using P here and hit enter. It has asked for the password. I have given the password. There is some issue. Okay, access denied for user root. We cannot connect to root using like this. So let me see what all databases we have and what all users we have. So for that, MySQL -u root -p password, show databases. There is a database called cards, and I think cards_user is the user. So let me connect to that. Yeah, cards_user. Let me validate the password here. Yes, it is working. Now let me try this one as cards_user username. Okay. Yeah, so for list tables, I need to give the database name also. As I didn't give the database, it didn't return anything. So I'm going back, and you can actually give the database here if you want to run the commands such as list tables. So the database name is cards. So I'm typing cards here. Now we will see the tables that are created in cards database. I think there are no data tables, yeah, MySQL user cards in the database. That's why it is not showing up anything. Let me run some other commands such as list databases. Instead of list tables, I am using list databases, which will list the databases for which cards_user have access to. Databases. And hit enter. I think I have given wrong password. Yeah, now you can see that cards_user as a user have access to information schema and cards database. Now let us run list tables on information schema rather than cards. And hit enter. So you can see that there are a bunch of tables available here. So now we can actually create the tables and run the Sqoop commands. If you want to understand how that can be done, you can go to my GitHub account. and go to repository code and click on Hadoop and click on EDW, Cloudera, Sqoop, and there are many scripts that are available here, which you can watch, and you can learn more about syntax and semantics of Sqoop. And also, as part of our channel, you can search for Apache Sqoop. There is a playlist, and you can follow that to understand more about all these commands. It has almost everything related to Sqoop. Okay, and validation will be done the same way as we have done earlier with pig and all. Sqoop will run as MapReduce jobs. You have to go to resource manager or job history server of MapReduce, and you should be able to watch the logs through web interface to troubleshoot the issues. And let's see what all is remaining. Yeah, Sqoop does not store log files anywhere. So if you see here, when we run these commands, there were some issues with respect to passwords and all those things, but those details will not be logged anywhere. If you have to capture that information, you have to use this notation. This is a Linux based redirection. So 0 for standard in, 1 for standard out, and 2 for standard error. So if you want to capture errors, you have to use 2, and then you have to redirect to standard out, which is &1. Okay, and hit enter. Now I am typing incorrect password, which should throw a error, and it will be displayed here. If you want to redirect to a file, what you have to do is sqoop.log. You can give the log file name. Either you can use single greater than or double greater than to concatenate to the existing file. Now if you see, we didn't see the error here, even though I typed the incorrect password, but it will be redirected to sqoop.log. So you can actually view sqoop.log and see the error. Okay, so this is how you can redirect the errors that are generated by Sqoop. On top of log, on top of errors, if the command is successful, right? So earlier the command was failed because of incorrect password. Now I am giving the right password. Okay, and the output came here. And if you look at sqoop.log file, it has only first few lines. Okay, because we have redirected the standard out into the file, and standard error into the file, and the output of the command will be printed here as standard out, not standard error. Because this is related to standard out, in the log file we didn't see this output, only we have seen the errors. So if you want to store output in one file and errors in another file, the way it should be done is like this. Okay, for errors to redirect using this one, so it will be writing all the errors to sqoop.log, and if you want to write the output, you have to use 1, you have to redirect to sqoop.out. So this will have the output of the command, which are list of tables, and hit enter. Okay, actually it should have prompted for the password. Let us see. Okay, I know why there is issue. The reason is here I didn't give the space. If you see here, there was no space. That's why it failed earlier. Now still there was some issue. Yeah, so sqoop.log is created, and there is that invalid error, invalid password error. You can actually look into sqoop.log So there is error because it didn't take the password. So I think when it comes to using both redirections, there seems to be some issue. So instead of using -p to prompt for the password, what I will do is password. I will give the password directly here, which is ITversity, and hit enter. Now the output of the command, which is 1, will be redirected to sqoop.out, and the error will, if there are any errors or if there is any other information which is generated as standout, will be returned to sqoop.log. You can do ls-ltr, you can look into sqoop.out, which have the list of tables, okay, and then sqoop.log, which have just few lines of information earlier, which is generated as Sqoop standard out. Okay, so this is how you can redirect the output to one file and logs to another file. This is very important thing which you need to keep in mind while running the Sqoop jobs, because Sqoop does not generate any logs for you. You have to redirect like this, and then you have to wrap an application around the Sqoop commands to automate the process. So just understanding Sqoop is not enough. You need to integrate with other programming languages to actually come up with a data integration framework to load data into the Hadoop cluster. And then I have already taken care of the Sqoop demo. That's it for Sqoop for now. If you want to learn more, go to the channel and go through the Apache Sqoop playlist, and you will learn quite a bit of it. And understanding the Sqoop commands for administrators is very, very important, but they don't need to automate the process. It is the responsibility of the developers. That being said, I hope you are enjoying the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about big data, Hadoop, please join my LinkedIn group called ITversity-Big Data. If you want to discuss further about certifications, please join my LinkedIn group called ITversity-Certifications. And finally, if you are not subscribed to my channel yet, please do so. And also, if you live in countries such as US, UK, where fan funding is available, you will see a section called support this channel here. You can fund with as much contribution as you want, so that I can come up with more and more content like this over time. Thank you. Bye.